Hello, everybody, and welcome to episode 15 of Going Meta, series on graph semantics and knowledge graphs. I'm Alex. Hi, welcome everybody, and I'm very happy to have you here, Jesus.
Hey Alex, very happy. It's my favorite time of the month, right? I was going to say it's the initial agreement was the first Tuesday of the month, although we've had to occasionally, but it's definitely beginning of the month, right? First week of the month. So right.
Absolutely. I think we were pretty close. We kept it closely to almost all of these episodes happens on the first Tuesday of the month. Every now and then there is an odd one where it couldn't happen on the first Tuesday of the month. This is one of those. So it's happening on the first Wednesday of the month at 4 p.m. instead of at 5 p.m. So a slightly different time and date, but who's counting?
Yeah, exactly. No, but I'm still super happy that we've managed to keep the regularity. Yeah. I missed a single one since we started, and that's the important thing. So number 50, that's amazing.
It is amazing. So I'm really excited about today. I'm interested to learn and to see about how to build. The topic is called building a semantic data app with Streamlit. So I think that sounds pretty cool. Sounds exciting. Before we dive in, I'd like to spend once more a few seconds on what's coming up, and particularly about the training series, which is finding its last event already next Wednesday on the 12th of April. Garrett goes into Spring Data, Neo4j, app development, and overview introduction training. So if you are more on the developers build an app, fitting to today's topic, I guess, app building with Neo4j kind of world from Java, then this episode is definitely interesting for you. We give an overview, we give some hands-on sessions, and we show how to work with Spring Data and Neo4j. So I think that's going to be an interesting session. I hope to see you there. The registration link is in the chat. So register, please. Yeah. All right. But I think with that, I said my piece, and we can go into the meta world, meta sphere.
Yeah, we're really gonna go meta today. So that's good. Always like it. Excellent. So let's that as usual, a last minute title, but the idea is, we're trying to. One of the things that I've been thinking is that sometimes we stay too much in the back. We show how we can enable cool things from Neo4j with Neo Semantics, bringing semantics ontologies and things like that. But sometimes we just give a hint of what that can look like for a consumer, right? And we don't always go into what can a front end look like, or what. And I wanted to explore that. With some of the principles are similar to things we've done before, and I'll try to connect with these ideas. But this time, and using, I'm new to Streamlit, but I think it's pretty cool, and it's a great library to build, quick data apps and with basic knowledge of Python, and that's what I'm going to use. That, and also, I got the inspiration from the great Mark Needham, who you might have seen that recently published a also using Streamlit in a different context. But thought that might be cool to put something, and if we add this layer of semantic, that can make it a perfect fit for our next going meta. So that's the plan for today. So if you want, as usual, I'm going to start sharing my screen. So share screen. Let me know when. I should have probably done this before. I can share my whole window, I suppose. So that would be the one.
Easiest.
Window entire screen. That's what I want to do. Yeah, exactly. Sorry. So let me know when you can see it. I'm trying to get this out of the way, and you should have my browser in front of you, hopefully.
Yep, there it is.
I'm going to go on slideshow. As usual, just a tiny bit of context, and I'll quickly go straight into the code. But yeah, the idea is to build a semantic data app with Streamlit. And I emphasize on the semantic part because that's fundamental in this series. And the idea is quite straightforward. I mean, we've touched on that different times. So we said that a knowledge graph is a combination of data, connected data in EFJ, in a graph, enriched with some semantics, with some explicit representation of the meaning of your data. And we've seen many examples of that last month. Sorry, we're talking about taxonomies, and we show how a taxonomy is a way of capturing knowledge, right? Because by classifying things, you're somehow making it explicit the fact that things are related to each other based on the place that they take in the taxonomy. And there's many other ways, right? And we've seen ontologies as a way of doing it. But the idea, I mean, the reason why we want to do that is because by bringing this explicit knowledge and building a knowledge graph effectively, what you're doing is moving from a place where data is simple and basic, and anything smart has to be done in the application, to a place where the data is enriched with some semantics. That's the semantic layer that we want to add, the kind of secret sauce that we're going to put on top of our graph, connected data, so that the application does not need to know everything. I mean, it can delegate a little bit of the logic into what we put into the graph. And so that's the same concept of a semantic layer that's becoming quite popular these days. But the idea is that, I mean, let's remove part of the business logic from the application, and let's put it closer to the data. Because by doing that, well, first of all, we make it explicit. We understand more about our data, and we make it reusable. So it's not, if every time you build an application, you have to bring in the logic to interpret this table, this column, this node, this relationship. We're kind of reinventing the wheel every time. And that's what we don't want to do. We want to, let's put some of that smart close to the data. In our case, as part of the graph, so really as close as it can be to the data, so that the application logic can become, lighter and make that knowledge reusable. So that's the principle. Does that make sense?
Mm-hmm. Yeah, it makes sense.
Perfect. Good. So what actually that looks like, and again, I'm reusing images from here and there, is we're going to have a Neo4j instance, and that's what I'm going to start, where we have some data as in a graph, and I'm going to use the movies database, a kind of a variant of it that has been enriched a little bit. And what I'm going to do is add to the graph the explicit semantics. I'm going to put an ontology on top of it, and by doing that, and with the help of new semantics, we're going to be able to combine the two and do smart things. So actually, this Streamlit that you see, I mean, the screen capture that you see to the right should be on top, because it's actually a consumer. So we will have our Streamlit application interacting with the graph and using the information in the ontology to basically drive the behavior that we expect, which is a semantic. Let's call it like that. Semantic behavior. It's a semantic exploration of the content of the graph. So that's the idea. That's what we're going to do. Does it make sense?
Yeah, that sounds cool. I mean, I think particularly when we go over this, and here, not particularly singling out this series, but generally when we talk about Neo4j graph database stuff, it's obviously we talk about always more or less a little bit more about the backend side of the house instead of the front end side of the house. So seeing an app, seeing a user's perspective, and seeing that side is super interesting and exciting. And obviously for a user, it makes sense. Well, a user does not care what's underneath, but as a developer, where you develop for a user, I guess you don't develop just for yourself. You develop for somebody that's using it, and it could be an application that sits on top of something. Sometimes it is not the case, but more or less, oftentimes it is the case. And then seeing that also in today, I think is very interesting. So I'm looking forward to it.
Excellent. That's good. Yeah, and that's the whole point. And sometimes, it's I suppose I'm convinced that there's some technical people joining us, and these also kind of helps somehow giving inspiration of making it real, actually. So hey, I can build this kind of general purpose front end that will consume the information in my graph. I mean, just by giving it an ontology. So that's totally the idea, and but still linking it to the concept that we have been talking for the last few months. Good. So that's our starting. That's the graph. This is, of course, as usual, I'm going to be sharing all that. So you will see some familiar elements here. So this is the movie database, but it's a variant of it. I've kind of enriched it a little bit because the movie database is very simple. So starting from the same data set, what we see, and actually I'm going to run a query to describe what we have. So we have in this movie database, we have actors that act in movies. So the first difference, as you can see, is that we have explicit notion of an actor, whereas in the standard one, you only have person and movie, I think, right?
Person,
so
movie, true.
A bit more specific. So, and at the same time, we have a directors that direct a movie, and there's a specific label for it. So there will be a director directing the movie. And I've also extended with a place, some geographical information, place of birth for some for all the person nodes, basically. So these will connect to something that is a place. And I don't know, just to complete the pattern, let's say, okay, we're looking for an actor that acts in a movie, and he's born in the same place as the director. Let's call this is the actor, and the pattern will be completed like that, right? So we will say same place of birth applies to both A, which is it's a long string, but you follow what I'm doing.
That is a long one, yeah.
The end, where basically by reusing the A, I'm indicating that I want this to be kind of a loop, right? So start with the actor, get to the movie, get to the director, place of birth, and ultimately the place of birth is the same as the one for the actor. Let's call that, I don't know, let's call this a pattern. And let's see if we have any examples of that. Many, but I don't know. That's fine if there's at least one. There we go.
Yeah.
Okay, so the movie is A Few Good Men, and we have few. Oh no, it's not that one. I thought it was. It's As Good as It Gets. Well, whatever.
Okay, that's okay.
One, but anyway, that doesn't make any difference. So right, and we see that both the director James Brooks and Cuba Gooding Jr., actor director, were both born in the US, actually New York City. I mean, it's not very. It's information that I extracted from Wikipedia. It just contains, the country, the region, as in the area, and the location. So it might be more or less complete in certain cases, but in this case, they both seem to come from New York. But that's the idea. There's some additional elements. So if we expand the movie, we'll see other actors. In this case, there's not more than that. But I've also classified the screenwriters with their own labels. So when we have one, it will be connected to the wrote relationship.
Okay, I see. Yeah, cool.
And, so yeah, I've added some additional labels to kind of enrich the graph and added this geographical information. So we have a graph, right? So that's something that that we start with, and like I say, I'm going to be sharing this now. My objective is to create a graph explorer that is driven by an ontology. So I'm going to, and first of all, why do I want to create that ontology? Because you might say, I mean, anyone might say, hey, Neo4j is kind of a self-describing database. So I can, even if I don't know what's in there, I could go and call the DB schema visualization or DB schema, and it will tell me what's in the graph. So I can kind of introspect what's in there. And to some extent, you can do it with other databases. But let's see what the problem is with that. So if I do its DB schema visualization, well, if I remove some of the elements that we don't need now, which are there for the N style reset. So we're going to see that well, it's not as clear as I would have liked, and there is a reason for that, of course. So we see that there's a central category which is movie. We have actors, directors, screenwriters, and producers, and they all are connected. Well, or some of them are connected to the place of birth. But we see that there's kind of I wouldn't call it spurious relationships, but it's telling me that an actor can act in, can write, can direct, which is not incorrect, but it's not as clear as I would have liked. And the reason for that, as you can imagine, is that there are nodes that have multiple roles, right? So we have.
I see. Yes. Okay.
So the moment you have Tom Hanks, who happens to be an actor in a movie, but director in another one and producer in another one, then you have an instance of an actor that also directs. And it's not really the actor, it's because the actor in that particular context is also a director. So, but this is difficult to tell, right? And because when you introspect, you get based on the instances, right? Because again, in the FJ, you don't really formalize the schema. That's exactly what we're going to do with the ontology. I mean, you can define some constraints, as we know, but you don't really go and tell, hey, there is the notion of a director, and a director directs a movie and has these and that characteristics. So you don't do that. And that's exactly what the ontology is going to provide. So the ontology gives me the opportunity to define formally what the elements in my domain are and how they relate to each other. So it's kind of, again, it's a proper schema, but without having the rigidity of a relational schema where it's also a set of constraints. So it's kind of a describing schema, if you want. So that's exactly what I'm going to try to add. And normally here we would go to maybe take a text document, a text application, and write some some OWL or RDFS. So instead of doing that today, my plan was to use Protege. Protege, I've mentioned this before. This is an open source public ontology development tool created by Stanford University. And I'm going to show, not create a whole ontology, but because we've got some questions on, hey, how do we do the whole process from scratch? And I will not go into proper modeling. It's not the purpose of the session. It's just what's the mechanics of it and how do we use that in our case. So just to show how it would go, I will not create one, but I'll say let's start by defining, for example, I don't know, screenwriter. I'm going to define this portion of the graph, right? Screenwriter is connected to a movie, and screenwriter is the one who writes. So the relationship is wrote. So what I would do, well, first of all, because in an ontology everything's uniquely identified, you have to define namespace, and we can say something like neil4j.com vocabularies, and this is my movies vocabulary. Just in this case, it's random. I'm just going to use it in this context. Here's important if we wanted to align, to reuse some external vocabulary, schema.org, things like that. We won't go into that today, but of course, that's where it all goes in the end. So we have our namespace, and I'm going to start defining some entities. I'll start by defining classes. So I'm going to define the notion of a screenwriter. So everything is a subcategory of thing. Thing is kind of in OWL, the overarching, top level container. Everything is a thing, and everything is a subcategory of thing. So when I define a screenwriter, this is what I do. I create a class, and I can provide annotations for it. This is useful because what I'm doing is I'm providing a schema that then my application is going to consume. So maybe it's useful to provide some kind of documentation, right? Some kind of human readable description of what a screenwriter is. So say the person responsible for writing the script. Of course, in this case, it's we're playing around, but it could be some important details. For example, what's the level, the type of information that you expect to find? What are the semantics of a screenwriter? I mean, I think more of a if we're looking at products, customer orders. I mean, these are more critical concepts in an organization. So maybe a formal definition, as for example, for me. A customer is someone that has purchased something from us. It's not a customer if our sales team is talking to them. So these kind of definitions might be important and will go typically in an ontology and help whoever the consumer is understanding what information is in there, right? So natural language and human readable. I can specify the language because, again, I think we've touched and we haven't. That's a good idea for a topic. We can bring multilingual descriptions to an ontology, so we can have, what screenwriter would be like in Spanish, in guionista. You could put it in French, and you could use the same knowledge and repurpose it in different contexts. I don't know, how do you say screenwriter in German?
Good question. Screenwriter.
I was expecting that one.
I didn't know.
Anyway,
What's it?
I
don't know.
That is a word in German.
Drehbuchschreiber, probably. Drehbuchautor. Yeah, that's what it is.
So we can. The thing is, you can add as many annotations as you like. So you can add another comment. For example, I could take the Spanish one. Encargada. The guion, right? Something like that. And I could say, well, this is the description in Spanish, right? And you can have multiple ones, and then again use that and consume that depending on which is the preference of your client, of your consumer in this case. I won't, I'll clean that for now, but that's entirely possible. But again, let's not diverge too much. So we've defined the category screenwriter, and the other one that we wanted to define is the movie, right? So there's another category which is movie. And I will do something similar. I would say this is, this is. I'm horrible at coming up with this. What I've been doing in the examples. I was going. Let me do it now. So if I've been to Wikidata and cheekily copying the description, hey, a film or a movie is a sequence of images that give the impression something like, anyway. Actually, we could do that to find what.
It's an interesting.
There you go. So,
I mean, it's. Yeah.
Don't have the German definition. Damn it! I was going to test you if it was correct, the one that you said before, screenwriter. Anyway.
Sorry.
Good. So anyway, so we have our definition of a movie in English. We save it. So it's just a comment. And now we were going to, if you remember, we had in our graph, screenwriter relates to a movie because it's connected through the wrote relationship, and the wrote indicates that this person wrote the script for that movie. So the way to define relationships in an ontology is what's called object properties. An object property is the equivalent of a relationship in a property graph. So we call this wrote, and everything again is a subcategory of the top level one. So it's wrote, and for a relationship or an object property, we define what's called the domain and the range, which is the from and the to. So wrote will connect a screenwriter to range is the target to a movie. Right, so basically we're saying that wrote is a relationship that connects screenwriter to a movie, and like before we can give it a description. We can say connection connects screen writer to the movie. He writes. I mean, I'm totally improvising this, but you see what we're going through, right? So this is a descriptive sentence that explain what this relationship is. So we'll just model this one, and we'll go with some properties, some we would call attributes or properties of a node. These are data properties.
Yeah.
So in our case, we had that a screenwriter would have a, we probably don't see it here, but we will see it in this case. So a screenwriter has a name and a born property, name and born, the date of birth and the name. So as usual, we come here and we define a data property, which is the name. And we can provide an annotation, and we can say contains the first and last name for a person, because we're a screenwriter, but anyway. And this is my description in English. Okay. And like we did before, the name, we have to specify what does it apply to, what type of entities. So again, domain, it would apply to person in the general case, but because we're just defining screenwriter here, we would say that it applies to screenwriter. And the range in that case, because it's a property, is not going to be another type of another node. It's going to be a data type. And in this case, the name is going to be a string. And we use the XML schema data type indicating.
So if we were to have a person main category, let's say, and underneath the person, everybody would be like screenwriter, actor, director, producer, whatever else there is. shopkeeper, then we would just have to put it to the category itself.
Good question. Hold that thought, because we're going to get to that in a minute.
Okay.
So that's a very good point, because like I said before, we're not doing the whole modeling, and you're totally right. I mean, I'm not going to define name for screenwriter and then having to do it for every possible role. So you would define it, as high up. This is a common property for every person, and then you would describe how a person can be broken down in multiple others. We'll get to that in a minute. And yes, that's the way you would normally do it. But because I said I just wanted to create a small portion of it in our world, only screenwriters and movies exist. I associate the property to that one. But yes, we'll get back to that in a minute. And yeah, the other one, just to complete, was the one that we call born, which was a number indicating the date of birth, right?
Yep.
Actually, it's the year of birth in our database. That's the kind of important information, right? Because if you're a consumer,
exactly, yeah,
you're going to get just a number, and this is where this can be informative. And well, just like we did before, the born applies to in our case, the screenwriter, although it naturally should be a person property, and in this case, it's actually an integer. Right? So we indicate that here. Well, that's probably enough. I mean, I could go on, and what I'll do in a minute, once we see the whole thing, is load one that I've created in preparation and show what a complete ontology may look like. But that's pretty much the process. So you define your categories, your classes, you define your relationships as object properties, you connect them to the classes, and the same with the data properties. So once you have that, what you can do is you save that. And I'm going to give these a name. You specify the syntax. Remember that what we're doing is through our UI is we're writing our RDF. We're writing OWL. So we can choose the syntax, and the more readable is turtle. Not that we care, because this is going to be consumed by Neo Semantics when we load it into Neo. But if we have a look, it's going to be nicer to understand if we use turtle. So, right, let's give it a name. We can call this screenwriter. Let's call it V. Just and now it's saved, and we have it in download. So good. So let's bring that into Neo4j. And to do that, as you know, we have to create a graph configuration. We're going to import RDF. Keep in mind that this, actually might be worth showing what this looks like. Let me open that in a text document. And if I open the screenwriter, just very briefly, I don't want to spend time on that, but you see how that's generated an RDF serialization in Turtle, where we see the different elements. So the object properties are here.
Yes.
Road with the domain and the range and the comments, the properties, and the classes here at the bottom. So nothing unusual. So this is already on my drive, on my disk saved. And what I'm going to do is I'm going to import it in the usual way. So I have to create a. I'm going to copy some fragments so that I don't make mistakes. But here, as you know, we have to define the graph config before we can import any RDF. And then just to import my ontology, what I'm going to do is call my n10s onto import. It's not inline. I'm going to read it from disk, so it's fetch. And all I have to pass is the location in the serialization format, which is Turkey. And the location is, I'm going to copy it from here, is in my downloads. And I think we called it screenwriter.
I think so, yes.
Let's make sure that it's screenwriter.ttl. Perfect. So if I import that, it will tell me that it's ingested all triples in there, except one, which is probably the definition of the ontology, which we don't need. And now we see a bunch of additional elements. So we see classes, and we see an SCO, hopefully. Well, not SCO, sorry, domain and range, which we have defined. Let's see what that looks like. So if I go and look at the classes, as expected, we have two classes. movies, and screenwriters, which is exactly what I defined. We see that we have imported the comments that we created, the names, the URIs. Remember that everything is uniquely identified with a URI. And if we expand them, we will see that all the elements that we have created have been successfully imported. Let's look at that. So we had a road relationship that connected, actually. Let's make the class a bit bigger so that it's, there you go. So we have the two main categories, screenwriter and movie, and we said that the road relationship connects screenwriter to movie. So the road relationship has its domain, which is the start is screenwriter, and the range is movie. And then both movie and screenwriter, we didn't find any property for movie. We might want to review that, because otherwise it's going to look a bit poor. But anyway, that should be okay. So, and in addition to the relationship, we created two properties, born and name, that had as domain screenwriter, and as range, one was integer and the other one was a string. So that's the ontology that we have created. All good so far?
Yep.
So, right. So this is, as you can see, is just another graph that's sitting on top of my actual data graph. So that's the diagram that we were seeing before. We had our data and our description of our data on top of it. And now we're going to bring our semantic application. Let's look at it first, and then, well, let's start it actually, because it's in Streamlit. I need to run it. Hopefully that works, and it gives us an endpoint. Here we go. Let's go with screenwriter. And well, here's what we see. So that's, I wasn't expecting this browser to kick off, but anyway, it doesn't hurt. So, right. So what, as you can see, it's a very simple, we call it Semantic Explorer. And the first thing we see is that it's listing the, I hope it's readable. Shall I make it a bit bigger, maybe?
Maybe a little, yeah, that's good. No.
So it's telling me in this database, you will find nodes of the following types. And it's telling me there's movies and there's screenwriter. There's more than that, but because this is a Semantic Explorer that's entirely driven by the ontology, it's only aware of what I decide to publish in my ontology, which is another way of creating different interfaces or different ways of consuming the data.
So, sorry, Jesus, how did this, where does this come from?
Right.
The app? Or
yeah,
the browser window?
I'll get to the, I mean, I haven't gone into the code, but I have it running here in my PyCharm, so it's in kind of in development mode. But it's a Streamlit app. So all you have to do to run it is Streamlit run with the page in question, and I'll go into the code in a minute. But that starts a web server. And
okay. Here we go.
8501, and that's what we were seeing here. So this is what the semantic data app looks like. So I was describing what, and I'll go into the code to generate that, because the thing is, this is not model dependent. This is, like I say, this is going and looking at the ontology, and based on what it sees in the ontology, it will go and present the information in the browser. So it's listing only the categories that exist in the ontology, for example, movie and screenwriter in this case. And for each one of them, you can see to the left that it's giving me like a card describing what this screenwriter class is. And basically that's all the comments that we created, Alex. You see how screenwriter, we said, is a person responsible for writing a script. It has two properties, born and name, with types integer and string. That's the year of birth. That's the There's a relationship that's outgoing. That's what I indicate with the arrow. So there's a road relationship that connects screenwriter to movie. So it's giving me a complete description of the schema that I've described in my ontology. And it's basically telling me what the shape of my data, the structure, and the semantics of my data are. Okay. And then based on that, it's also being able to go and retrieve instances, examples of this particular entity. Okay. So again, for screenwriter, it's returning all the details about all the screenwriters that, but only the information that's described by the ontology. Does that make sense?
That makes sense. Yeah.
Good. And if I click on the movie, again, it's only showing me the node IDs because I did not define any property. If I go back to I forgot to create the title, but I should have come to after defining the movie, come to the data properties and say, hey, there's actually a new property that I did not define, which is probably the title, right? The title is the name
title of the movie. Yeah.
A name for the movie that's in English, and that applies like we did before. Domain applies to a movie, and the range is going to be a string in this case. And then we also had actually that's not a bad exercise. We can show that. And then there was the did we say it was what release? Did we? Let's have a look at a movie. So if I look at a movie, we have released. Okay, let's copy that.
You mean yeah? Okay.
Just to add the two properties, right?
To an additional property. Yeah.
Exactly. We can say this is it's the year when the movie was premiere. That's in English. Okay, that applies to my movie. And the range in this case is another integer because it's just the year. Okay, so we have a new version of the ontology. So I can now save this. I can save. So it should have updated my screenwriter ontology. And I can now come here and maybe update my ontology. I just need to rerun this. The input of the ontology, there's a bunch more triples being added. And if I re-explore that, I might need to actually rerun. Here you go. So I have my classes. And now if I expand movie, I see the additional elements. So I see the released and the title with the titles string and integer. And by magic, because I didn't change anything, that's the interesting thing. If I now come back again, look at that. The movie now has two additional properties, the title and the released, and there's a description for them here. So effectively what's happening is that as I add elements to my ontology, this semantic explorer is just consuming that ontology. It's reading, okay, you're describing your domain with this ontology. That's what I'm getting, and it's showing it in the card to the left. And based on that, I can build the query and retrieve the information about the data that exists in your graph based on that definition. Take a pause here. Does that make sense? Any questions on that?
Not for me, but I can obviously a good point of handing it out to the dear audience in chat. So if you're watching this and wondering, scratching and thinking, I didn't quite get that, type it in chat. Let us know if you have any comments, any other things you saw or had a remark on, then let us know. But it was it's pretty cool how this app basically builds itself almost. So you have to.
So it's just totally driven by the ontology. So you decide really how descriptive you want to be about your data, about your graph, and it will consume it. But let's take it one if we while we wait for questions, if any come up. What I wanted to describe is, I'm not going to do it manually all the way, but I have one example here, and I'm going to open it in this window. Another example, which I think I've called complete movie. That's the one. Complete movies for going meta. So if I open it, this is a richer description. So we have a bunch of classes. Look at that. That's probably more like you were thinking about before, right, Alex? So you have persons, but you would say, right, a proper way, and maybe here's where you want to align it, like we always do, right? We align it with the classification in DBpedia, in schema.org, and you want to combine with existing standards. You choose. But in this case, there's a richer description of, okay, persons can be artists, or they can be critics or producers, which aren't necessarily artistic people, but then you can be a performing artist and you're an actor, or a visual artist and you're a director, you can be a writer. So there's a rich taxonomy of different types of individuals. And in this type of ontology, what we would do is, okay, when I describe a person, sorry, I'm not very familiar with the interface. But you see that when I describe a person, and again, I've introduced multilingual descriptions here. Sorry, I have to improve my German. I'm not, I've only been able to
okay.
French. But
person is not so difficult. It's the same word.
Okay. But yeah, I'm not, my the simple applications that we created doesn't deal with multilingual, but it was straightforward. I leave that to our, interested readers, attendees to maybe take that code and extend it, because it would be just you could put a toggle here and say, put it in French, put it in Spanish, put it in German, and you would have exactly the same thing using the right element. But I wanted to keep it simple for this case. But back to your point that you mentioned before. So here we have all the data properties, and you said, hey, the name, right? As we said before, the name belongs in person. I don't want to replicate that. So the name is a property of a person. So if I don't know if there's a nicer way of seeing that. I think usage, maybe. There you go. See, that's I'm sorry, but I'm not very, very familiar with Protege, but it's that's it. So it's so born, it applies to person. Then for actor, we have specific things like the acted in relationship. So we have the domain, like we saw before, starting from an actor and connecting it to a movie. But the common properties can be moved up to, all the way to person. But, so here's a richer set of classes and a richer set of we have, movies, persons, places, and each one of them will have their own set of attributes, relationships, and for each one of them, as usual, I've tried to put a description. So acted in describes a person's involvement in a movie as an actor, and so on and so forth, right? So so this is a richer ontology. So what happens if we replace the ontology that we have with this richer one? And that's what we're going to do next. So let's go back to our browser. And I'm going to, a simple way of getting rid of the ontology is to do a match on all the resources. So that just, that leaves the graph unchanged and only gets rid of the ontology elements. Obviously, if we go to our application and we rerun it, now it says, hey, I'm lost. You're not describing any class, so I don't know how to process your graph. And of course, you could create some kind of specific logic, but that's exactly what we wanted to avoid. Remember at the beginning, lots of business logic in the app, not much in the data. We want to put more of that in the data and have a general purpose and simpler application. That's the idea. So let's do that. So I go back to here, and when I do input the ontology, instead of doing the screen writer, which is just the one that contains these, we're going to use the complete movies going meta. That's how we call it. Complete movies. I hope I typed it right. You could have a bunch more triples. There you go, 130. And now we will see that there is a richer taxonomy there, and we can even explore it visually here. So we have person at the top, we have producers, we have critics, we have artists, and then we have writers, performing artists, visual artists, actors, screenwriters. Well, you see how the information is organized exactly the way we did. And for each one of them, again, we have all the properties as we described them, right? For a person, we said that a person will have a born and a name, which then will flow all the way down to anything that's a subcategory of course, person. A person will be connected through the place of birth relationship. Let's make it a bit bigger. Place of birth. These will have, hopefully, on the range a place. So this is the other category that we define, and so on and so forth. So we can navigate it and we can visually explore it, because the key thing is just some more data. It's data that has a specific meaning, that describes my graph, and that my application is going to be able to consume. So let's go and bring back the application and see what sense can it make of this. And if I rerun, now there you go. So we have a much richer list, including all things that, and that's where you will probably see it come to life, because here we're looking at movies, and that's all the things that describe a movie, the title, the tagline, the release year, all the incoming and outgoing. In this case, they're all incoming relationships, so directed, acted in, and so on and so forth.
Yeah.
But what happens if I click on something that doesn't really exist in my graph? Because remember how we described the notion of a, I don't know, let's bring it up. So there's a visual artist, or even an artist, which aggregates actors, directors, screenwriters, that doesn't really exist in my database. So you can see what I'm going here, because we've done this in the past, right? So Semantics will be able to navigate the taxonomy and say, oh, you're interested in artists. Well, I know that artists have multiple, subcategories. So anything that's an actor, a director, or a screenwriter are actually instances of artists. So that's what you get for free by using this approach. And if you go and take, for example, where's artist?
Yeah, the top line in the middle. Yeah, there it is. Yeah.
There you go. So you see, well, first of all, the definition of an artist, it's inheriting, the definition of a person.
That's cool.
So that we know that it has a place of birth, and you're getting things that will be, in this case, it's listing all the things that are either, what did we say?
Directors, producers.
Yeah. No, not producer. Producer is not artistic. Is
producer, not artistic. That's true. Director and
directors, screenwriters, and actors. But you see the idea, right? So this is where the whole thing comes together, because you are first of all, you're providing a self-describing formal description of your graph. I mean, I'm probably using the description word too much, but our application is capable of using that to drive a completely general purpose front end or semantic data app, as we've called it, and the same with all the rest, right? So there's no notion of visual artist, but in our case, a visual artist is a director, right? Because that's how we define it, and or performing artist, and so on and so forth. But again, the idea is any graph that you may have, can go, anyone who's attending today can go and take the other one, the Northwind database. They can put an ontology on top, and they will get this front end to work for free, and even enrich it in the way they want, because you can decide to hide some elements, to create additional elements that don't exist in the graph, and have the inference happening on the fly. And that's I'll take a pause here, because that's pretty much it. I guess the last thing, without scaring people too much, is maybe having a look at the code to see what's happening behind the scenes. But it's it's literally 60 lines of code, believe it or not. So there's no more than that. So is Cypher. So shall we have a quick look at it?
Let's have a look at this. A couple of questions came in, but let's finish the segment first and do have a look at the code, and then go over.
Perfect. So let's bring it here. So before I open this, let me make this a bit bigger and hopefully more readable. Oops, that I wanted to make it bigger. There we go. Anyway, so there's let me compress this before I show the cipher. But there's three in total, like I was saying, is 70 lines of code. But there's three methods. I mean, of course, the connection. I mean, the usual. I use the Graph Science Library. I provide this is a local database, my credentials, and the database that I'm using. Simple, right? So we have a connection to my database. Then I have three methods, and I'll go into them because they're purely cipher. All we do there, the first method gets me the list of categories, and by that I mean which other classes defining my ontology. The second method is, given a selected class, give me all the details, and by details I mean give me the properties that are defined, give me the relationships that are defined. And the last one is give me all the instances, all the examples. So basically the third block in the application, right? So the first one, if you think, it populates this list, right? So give me all the classes that have been defined. The second one populates this part, give me all the details about a selected one. So when I pick critic, tell me everything about it. And the last one gives me instances of that particular selected instance. So that these are the three main functions. And then once I have that, and I'll get to that in a minute, all I do is lay it out in the screen. And this is really nothing. It's purely a presentation. So I have the header. I get my categories. That's what I call my function. and then I put them on a list. This is a radio element. So the radio element, you've seen how it presents them so that I can. I'm not super, I'm not a designer, so don't, I know that this approach might not be the best, but you can put it in different ways. It's a simple way of clicking on something and get it selected. There might be others, but a radio seemed a simple enough approach. So I put it on a radio, and basically I'm listing all the classes that were returned by the categories that I got from the database. Then to the left, and I put this on the sidebar. So when there is a selected class, of course, if there's no selected class, I cannot do that. And if there's an error message, no class selected, as you saw when there was no ontology. But if there's a class selected, what I do is I call the function that gets all the details about a class, and then I iterate over them, because this returns a rich structure with all the properties, the descriptions, etc., etc. And I put it using Markdown on the sidebar. So this Streamlit sidebar populates the left side of the screen. This gray. This is a default component. You don't need to take care of it. It looks beautiful, as you can see. And I put the selected class. I put the information about the class, which is essentially the definition. So it's a one-by-one list, pretty readable code. I mean, not my code, but Streamlit. And then I iterate over properties, iterate over the outgoing relationship, and then the incoming relationship. So that's pretty much it. Now the question is, what's in these methods? And that's where Cypher does the magic. So the first one, how do I get the categories? Well, you can imagine that the way to get the categories is just list all the classes. But because I want to be aware of the semantics and the idea that there can be classes that don't exist in my database but are in my ontology, what I do is I filter and just keep the ones that have some instances. So if there was, for whatever reason, a subcategory, let's call it, you said a baker, a butcher, or whatever, that's not in my database, I would filter it out because, and here is probably an optimization, but I was thinking of the case, hey, if someone comes and imports the whole schema.org, which defines 200 classes, right? And only one of them, actor or director, happens to be using my database. Do I still want a list of 200 classes, even if there's This is what I'm doing here. So I hope the code is easy to understand. But I'm basically saying, okay, get me all the classes, but filter them based on the ones that are actually in use. So that's the idea. And plus all the taxonomy. So that's what I'm doing. So it's 3 lines of Cypher, so not too bad. So that gets the categories. Then this is the chunky one. So when I get a category, I need to get everything about it. But again, it's not complicated. So I get a class, right? A selected class. And all I have to do is, get me all the domain, all the relationships that start or end at that class. So whenever there's a relationship, there will be a relationship node that will be connected through domain or through range, which means is it an incoming or an outgoing relationship? And based on that, I get all the details about that relationship. I get the name, I get the comment if there's one, I get the category at the other end, all the information there. I'm just navigating the ontology here, right? The same with the outgoing and the same with the properties. The properties create a property node, which normally will be connected through the domain. And basically that returns an object, if you want, with all these details that I'm going to use to drive the population of the sidebar panel. That's all. And finally, the last one, where I go a bit more meta, is where I apply the inference step. And you see the calls to new semantics, right?
Yes.
So instead of getting all the instances of a particular class, what I do is, okay, get me all the instances of that class and those that can be inferred as instances of that class. And so that's where also the semantic inference magic takes place. If you don't want that to happen, of course, you can do just a match on that particular label, and that would work as well. But I thought that would be interesting to build it into the application. And then finally, you populate the columns with the relevant ones defined in the ontology again. So that's basically when you define the headers based on the definition for a given artist, person, or any entity. So that's pretty much it. I mean, I know I went quickly through the code, but that's probably the kind of thing that people will want to consume offline, as usual, I'll put it on the GitHub repository, and feel free to check it out, to enrich it, to enhance it, to improve it. And I'd love to hear from you on that. So that was my content for today.
Cool. That was super good. Sorry. Thank you very much, Jesus. We had a couple of questions, so maybe let's go over them now. Tilak asks, what is OWL data property? Specifically, what is top?
Okay, so I suppose that's a question. Let me reshare my screen, and I'll.
I think it was a little bit earlier when you were.
Yeah, I suppose they're referring to the project, right? So when you define, can you reread? Is that OWL top object property?
OWL top data property, yeah, exactly.
Top data property, that would be here. So again, yes, in an ontology, I mean, everything hangs off kind of top level elements. So when we define in our ontology, in our, let's think in our graph, we have actors, we have persons, we have movies. So these are independent entities, but in the OWL, and OWL is the ontology language for RDF, everything hangs off a top level thing. And for classes, it happens to be called thing. So everything is a thing. So this is for advanced inferences. So in order to create, valid logic theories, everything has to be a subclass of something, right? To be able to, the open world assumption, closed world assumption. I will not go into that. There's kind of more sophisticated logic, but it's, for us, it's really irrelevant. I mean, the fact that, if you put it on a tree, everything hangs off a thing, which is a top level category that kind of the universe. Anything is an instance of a thing, movie, person, etc. The same applies to properties. So when you define acted in, directed, there's a top level, top object property that is the sub property of super property of everything, and the same applies to data type properties. So I would just keep it as a particularity of OWL, but wouldn't worry too much. Actually, when you look at the ontology that I show briefly, let me bring it up. This is not exported. Let me reopen the last item. Here we go. So when you see the serialization in Turtle, so you will see that road, even though formally it's a sub-property, as we see. Well, it's not here. That's the previous one. But the road is a sub-property of top object property. You will not see that exported. So it's just included, and maybe a confusing element for Prodigy. So maybe feedback for them if they're listening. Maybe some people get a bit confused by that.
Yeah. Sense. All right. Next question from Peter: is the ontology DB in the movies database, or is it separate?
Hang on a second. Can you repeat that? I got distracted. Yeah. So is the ontology?
Sorry. Is the ontology part database part, or he asks it in ontology DB, but I guess he means is the ontology part saved in with the movies database, or is it in a separate place?
That's a very, very good question, and the way I do it, and that can be. I was actually thinking about that very topic. So there's you can store the ontology with your data, and in our case, they're kind of independent graphs. There was no connection across them, so you have your. The linkage happens based on the matches on the labels. So you have a node that describes what a person is or what an actor is. And then you have nodes that are labeled as actor, but there's not a relationship between them. You can have that, and that's one option when you input data, but it tends to not be very useful because you can end up having a super dense node that's, every person links to the person node. I don't think that's particularly useful. So my normal approach is having it in the same graph. You could have it perfectly in a separate graph. I think that, data locality, data proximity is useful in this case, but it's entirely your choice. I mean, if you decide to have your instance data in one graph database and your ontologies in a separate database, it might complicate a little bit the Cypher, because you have to query. We have the notion of a composite query in Cypher. So you can say, this part of the query, run it against that database, and then continue on these other database. So if you decide to split it like that and have the ontology in one database and the data in another one, you still can write your cipher and get that working pretty much in the same way. So I hope that kind of answers the question. But in our case, yes, both were living in the same movies database as kind of separate independent graphs.
Yeah. Cool, thank you. Matthäus asks, would it be possible to have multiple labels to the nodes? In the Tom Hanks example, it would be possible that this node has a director label and an actor label at the same time. I think that's...
Yeah, absolutely. Yeah. And that was the reason, I think we mentioned it at the beginning, and that was the reason why the schema, so the DB schema visualization become a bit confusing, because you can have a node that plays multiple roles. So yeah, absolutely. So that's totally the case. And and the application, the semantic application that we built is aware of that and would treat it as, depending on which is the category that you've selected, it would apply the description in the ontology for that particular category. But yes, there is definitely the possibility of multi types.
Lanka asks about Protege. I shared the link again in chat. It's also in the video description. So if you want to try Protege yourself, the video link, the link to the tool is in the video description, and there seems to be, I think, at least Juan says there is also a web alternative.
Correct.
So that
Protege.
You don't even have to download the tool.
Yeah, there's I was actually using the local one because but yes, I'll put it on shall I put it on the chat? I don't know if that goes to everyone, but there's this web Protege, which is a kind of a lightweight version. Some of the things that you can do in the desktop application you cannot do online, but it should be rich enough for the kind of things that we've done today. You can definitely use web Protege as well. So and it's slightly different, the flow. So because it's cloud, you have to download the model that you've created, but it's pretty similar. Once you export it and you download it in the turtle format, and it would be pretty much the same. So yeah, I'll share the links for both.
I add the links into the into the video description as well. Eshwa, made a point. I guess it's not for today, but for general purposes, I guess could we add into the Streamlit app? Would it be possible to show also the nodes and the relationships into Semantic Explorer as a visualization of the graph eventually?
Absolutely. And you know what? I think this. I intentionally controlled myself and said, hey, let's provide a non-graph view of something that gets that leverage the value of the graph and that gets the insight from the graph, but that presents it in a completely tabular. If you had this semantic data up in front of you, you wouldn't be able to sell the fact that it's powered by a graph database.
True.
It's just again, it's reusable, it's versatile, it's semantics driven, but yes, just to again, we might want to add a link, but there's a component, I believe there's the notion of extensions to Streamlit, and there's one that does graph. It wouldn't be browser or Bloom. We have these other surfaces, but there's a Streamlit. I'll find it for you and post the link. It's a component. It's called component. So and it is called something. I'll find it because I was
the link to Streamlit itself will be in the video description. So if you're wondering where to find it, and I can once we find the graph visualization component, we can add it later on. Will the talk be available as video on demand? Yes, I shared the link as well. It will be the same link basically from now on till the end of YouTube.
Right, I found it. It's called a graph. It's called. Let me share my screen because if you go to the I'm sharing it already.
You're still sharing, yeah.
Okay, good. So that's this a graph. So if you go to the Streamlit components, so there's this one is based on React D3. So I haven't played with it, but feel free to. I think this takes you to maybe some example.
Perfect. Can you? Yeah. Oh, yeah, that's good.
So yes, you can. I suppose it will. You can access the code, and so this is contributed by probably the community. So yeah, documentation, demo, and everything. So yes, there's a number of really cool extensions that you can definitely add to enrich the.
Yep. Cool. Yeah, and I think with that, I think we're at the end with the episode 15 of Going Meta. I think it was a pretty cool one today. I liked it a lot, seeing this app, especially when it auto completed almost like the. I mean, not by magic, you had to write it in beforehand, but as to me, it looked like, oh my god, it automatically created all by magic. It was a little obviously behind the scenes, but in essence, if you only have to do it once, right? And then it's when you iterate over it, it's working with you. So
and that is I think the key takeaway here. So that the whole idea of adding a semantic layer is that you do it once and every consumer can benefit from that. And I think we'll get back to that topic, because it's becoming very popular, this idea of a semantic layer, not necessarily for things like data set exploration, but for the definition of metrics. I mean, it's very common when you have a data warehouse and you have multiple BI tools, multiple reports, and each one computes ARR in different ways. So because they all have their own calculations, why don't you push that definition closer to the data warehouse, close to the data, and then everyone will be in sync. We have a single unified definition that everyone is aligned with, and that you do once and everyone benefits from. So it's the same principle. Yep. We looked at visual, at exploration of a data set, but we'll touch on this idea of defining metrics on a graph, so that consumers. I was thinking of bringing Neodash into this, because Neodash could consume that too. And it would be a great example of saying, hey, the ontology is here. Whether you consume it from Streamlit, Neodash, but then would have been made for too long sessions. So we'll get back to that on future.
Maybe in the future, exactly.
Going Meta. So yeah, good. So I think
all
that's
right.
pretty much it.
I think that's it. Exactly. Thank you very much. Thank you very much, everybody, for watching, for your questions and comments. As usual, the material and everything else will be in the repository on GitHub, so you can try it out yourselves. Jesus is always happy if you give him some feedback, so let him know. Also, let us know if you like the episode by giving it a thumbs up and subscribing to the YouTube channel if you can. That gives us some more knowledge about what you like and what you want to see more in the future. And with that, I wish you a great rest of the week, and I'll see you soon at another live stream, hopefully anytime next week. All right, well then, take care everybody, and bye-bye. Thank you very much, Jesus, again.
Thank you. No, it's always great. See you all soon.